Okay, welcome to the Unit Testing in Java video series. What this video is going to answer are the questions: how do you design a good test scenario, and how do you write a good JUnit test? But before we get into that, let's make sure we understand what testing is. Alright, the purpose of testing is to prove the correctness of the program. So how do we define what is correct? Well, that's defined by the requirements. So we have many requirements, so we need many test cases. Therefore, the purpose of one test case is to prove the correctness of one requirement or part of one requirement. So what usually happens is one requirement generates many user stories, and then one user story generates many tests. And some of those tests are going to be unit tests. Now, unit tests are tests that exercise one method, or maybe a few methods that are related from one single class. You can think of a class as a unit, and collectively all the unit tests prove the functionality of that class or unit is correct. And another thing to note is that JUnit tests are intended to be automated. So we typically run them overnight, typically using a continuous integration system. So you may not know what a continuous integration system is. We'll just Google that. And you can see Wikipedia can define what continuous integration system is. So they do a lot of stuff, but what's most important is when developers are checking in their code, the continuous integration system will not only merge all the code using Git, but it will rerun all the tests, rerun the integration tests. And critical to this is that before each developer's bit of work is submitted, or actually on the integration system when it's submitted, it has to do a complete build and run all the unit tests, and all the unit tests must pass. Now that is a prerequisite before the commit is accepted. Okay, so this is what we typically do in industry, and so often you'll try to commit something that you think is working, but it will get rejected, and you'll get told that a certain unit test of someone else's failed, which usually means that you've broken someone else's code. All right. So the other point to notice, besides this continuous integration system of automated unit tests, the idea is that we run a lot of them and they take a long time. So therefore we want to automate them, but we also want to get a statistical report. Because they take a long time, we might run a lot of them overnight or run them once every hour. And so there's no humans involved. So there's no point in printing messages in your JUnit tests because nobody's going to read them. There's no humans reading the output of these JUnit tests. All right. Okay, now to understand this concept, you need to understand that test programs are different from application programs. You need to separate those two things. So the application programs is the real functionality that's meeting the requirements. And the test programs are things that operate on that, but they're not the actual application itself. So we want to separate those two things. You don't want to put application code in the JUnit test, and you don't want to put methods that are only useful for testing inside the application code, because these two things have a different purpose. The application code is to meet the requirements, whereas the test code is to automate the proof of correctness. The application code is deployed and run by the users, whereas the test code is not. Right, so this little illustration just shows you the test programs are exercising the public APIs, whatever we have in the proper application, and then the information we get back is information about correctness, whether tests passed or failed. All right. So we're almost finished this introduction. There are three broad steps in unit testing. The first step is to design a test scenario, and after we've done that, then we can write a JUnit test, in Java code, and then if we're doing TDD, we'll write that test code first. And then after that, the third step would be to implement the requirements that should make that test pass. And then we can run it and see if it passes. And if not, we either fix the test or fix the application code until it does pass. Okay, so in the next video, we will design a scenario for one of the requirements in the banking system, which we saw in the previous series on brainstorming object-oriented design and CRC cards. Okay, so I'll see you in the next video.